You are welcome to Math Demystified.
Today we shall be dealing with probability. We shall take few examples on elementary probability. Number one question. In a large crowd, there are 3 times as many men as women. 3 people are chosen at random. Assuming that there are so many people that choosing 3 has a negligible effect on the proportion of men to women, find the probability that they are: question A, all men; question B, 2 women and 1 man. Let's solve this question. This question is telling us that it's in a large crowd. And looking at the question, they said there are 3 times as many men as women. So men ratio women equals 3:1. So that tells us that the probability of picking a man equals 3n/4n. And look at the ratio there. Then the probability of picking a woman will also be n/4n. So we can cut this to their lowest term such that the probability of picking a man will now be 3/4, and the probability of picking a woman will now be 1/4. You may ask, why don't we just put 3/4 and 1/4? And why are we using the n? The time is in a large crowd. So if I just say it is 3/4 and say it's 1/4, that means that I'm saying that we only have 3 men and 1 woman in the whole crowd, and that is not true. So this is just giving us the ratio. So we multiply by n and by n. And of course, this will cut out and still give you back what you have. So when you are solving a question in probability and they give you ratio, do not forget to factor in the unknown when you are solving the question. So let's answer the first question. In this question, we are asked to choose 3 people, and we are told to find that they are all men. So the first question, probability that they are all men, all the 3 are men, will be m. The first is a man, second is a man, third is a man. And that will give us 3/4 times 3/4 times 3/4, and that happens to be 27/64. As simple as that. The second question says 2 women and 1 man. And that means 2 women, WW man. That means the first 2 can be women, followed by a man. Or, if you look at it critically, the first can be a woman, followed by a man, then a woman. Or it could be that the first is the man, followed by woman and woman. These are the 3 options that we have. And looking at it, we have exactly the same thing in all of them. There are 2 women and there's just a single man. I can write this as 3 times the probability of any of them. So let me pick WWM. So let's solve that. That will give us 3 into probability of picking a woman is 1/4. 1/4 times 3/4 for picking a man. And when you multiply this, you will discover that this multiplying the numerator will give you 9 out of 64. That's 9/64. And you can't cut this any further. And that is the answer. Question number 2. The probability of a seed germinating is 1/3. If 3 of the seeds are planted, what is the probability that question A, none germinate? Question B, at least 1 will germinate? Question C, only 1 will germinate? So let's start. In this question, we are given the probability of a seed germinating as 1/3. What we want to do next is to find the probability that the seed will not germinate. So the probability that this same seed will not germinate, you see, germinate, will not germinate, that is G complement, will be equal to 1 minus the probability that the seed will germinate. That is 1/3, and that will give you 2/3. So anytime you are given the probability that something will happen, it is important you quickly find the probability that it will not happen. It helps you to be able to solve the question properly. Now, the question is now asking us that if 3 seeds are planted, what's the probability that none will germinate? So the first question is saying probability that none of them will germinate. The first seed will not germinate, the second seed will not germinate, the third seed will not germinate. So, and that will give us 2/3 times 2/3 times 2/3. And the answer is 8/27. It is as simple as that. The B part of the question. The B part of the question says that at least 1 will germinate. I want us to list all the possibilities before I do what I'm supposed to do. At least 1 will germinate. Let's list all that. That means that all of them can germinate. Only 2 can germinate. When I'm arranging that only 2 can germinate, I'll have 3 options for only 2 can germinate. Then that only 1 can germinate, I will also have 3 options that only 1 can germinate. If you list them, that's what you will see. This will give me 3 options. Now this can be at the center and it can start. This one can be at the center and it can end. So I have 3 options for each of them. Giving me 6, 7, I need 3. These are 7 options out of 8 options. The only one that is not here is that none of them will germinate. So instead of calculating for all these 7, I will just do 1 minus this. Instead of doing probability of this, probability of this, probability of this, and add together, I'll just say 1 minus probability of this, and that will be my answer. Let's do that. And that will be probability that at least 1 will germinate will be equal to 1 minus probability that none will germinate. And that will give us 1 minus, we just calculated this up here, and our answer is 8/27. So if you solve this properly, your answer should be 19/27. And that is it. The last part of the question says that only 1 will germinate. That will be probability that this will germinate, second will not germinate, third will not germinate. If I look at this properly, I'm going to have 3 options of this. So this can be at the center where the first will not germinate, second will germinate, third will germinate, or the first 2 will germinate, the third will not germinate. This can be here, giving me the second option, or it could be at the end, giving me the third option. So there are 3 types of this. So I have this. Then that will be equal to 3 bracket probability that it will germinate from what we are given is 1/3. Then we have times probability that it will not germinate is 2/3 times 2/3. And if I calculate that properly, this can cancel one of this. And my final answer here will now be 4/9. That's how to solve it. Question number 3. If 2 cards are drawn from a pack without replacement? What is the probability of getting A, an ace, and a king? B, 2 aces. In a pack of playing cards, there are 52 cards. And in those 52 cards, 4 of them are aces and 4 are kings. So the probability, going by the first question, if 2 cards are drawn, what's the probability of getting an ace and a king? In a pack of playing cards, there are 52 cards. And we are told from the pack of playing cards that there are 4 aces and there are 4 kings. So the question is asking us that if I want to pick 2 cards, the probability of picking an ace and a king will be written like this: an ace and a king, which I can write as this. Or let me explain that. Probability of picking an ace and a king, you give all the possible options that you have. I could pick an ace the first time, pick a king the second time, or I could pick a king the first time, then followed by an ace. And this all means plus. So I will have probability of A, K, plus probability of K, A. And please note, before I split the P into 2 brackets, they were both in a single bracket. The P was outside, the O was inside. When I split them, the plus will be here. Please note that you don't put plus here and you don't put O here. And that's how it should be written. Let's put those values here. There are 4 of these. That will be 4 out of 52. Do not forget it is without replacement. So as soon as you pick the first one, this one has to be reduced to 51. I'm picking a king the first time, so this one too will be 4. Plus, I'm picking a king the first time, 4 out of 52, times, this one will quickly reduce to 51. I'm picking an ace the first time, it will still be 4. So you solve this. When you solve it, this and this are exactly the same thing. So I could write it like this and just write, they are the same thing. This is the same thing as this. So I could write 2 times 4 times 4 over 52 times 51, which will give me 2 into 16 over 2652. And when you cut this, your answer will be 8 over 663. And that's how to solve it. The B part of the question is saying probability that the 2 of them are aces. So probability, the first one is an ace, and the second one too is an ace. That's the only option. All right? But they are the same thing. That's the only option. So in this case, I'm picking an ace the first time. There are 4 out of 52, and this one reduces to 51. I picked 1 out of the 4. So this one becomes 3. So when you cut, you could multiply and you will have 12 over 2652. And your final answer will now be 1 over 221. You can see it's as simple as that. When they are both the same thing, that is the only option. That's the only way you can solve it. Then when they are different, you arrange all the possible options you can have and you solve. Question number 4. It is assumed that when children are born, they are equally likely to be boys or girls. What is the probability that a family of 4 children contains, question A, 3 boys and 1 girl? Question B, 2 boys and 2 girls. He said it is assumed that when children are born, they are equally likely to be boys or girls. So if they are equally likely to be boys or girls, that means probability of picking a boy equals half, and the probability of picking a girl is equal to half. Equally likely. They are the same thing. And since there are only 2 of them, it should be half and a half. So So if there are 3 of them, it will be 1/3, 1/3, 1/3 if they are equally likely. You note that. So the question is now asking us, what is the probability that a family of 4 children contains 3 boys and 1 girl? 3 boys and 1 girl. That's the probability, 3 boys. B, 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 G. 3 boys and 1 girl. You see that like this? Or I can have B, the first is boy, second is boy, a girl, then a boy. I could even have the first to be a boy, followed by a girl, then boy, boy. Then we could have that the first is a girl, then the boy, the boy, the boy. These are the ways that we can arrange those things. So if you look at this very well, since they're equally likely, this is going to be half, 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 half. So I have the same thing all over. So I could just pick one of them and multiply by 4. 4 into probability of boy, 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 girl. And that will give you 4 into half times half times half times half. And this, we cancel this. So I end up having 1/4. And that's my answer. Give all the possible arrangements of this. No, they are not all the same thing. So all the possible arrangements. And you just solve. And that is it. The last part of the question says 2 boys and 2 girls. Let's list all the possible options. I can have the first to be boy, second boy, girl, girl. Or I could have B, G, B, G. Or we could even have B, G, G, B. Or it could even be G, G, B, B, which is the reverse of this. Or it could be the reverse of this one too, which is G, B, G, B. Alright? Or we could reverse that one too, and we could have G, B, B, G. I think these are all the options that we have. If you check it properly, that's all the options we have. And looking at this, like we did before, we have 2 boys, 2 girls in all. Since they are equally likely, we don't have any problem. So it's the same thing as writing 6. 1, 2, 3, 4, 5, 6. 6 of the probability of any of them, D, B, G, G. And that will give us 6 into this 1/2 times 1/2 times 1/2 times 1/2. And that will leave us with this, cutting this to be 3. And that will be 3/8. I decided to give this question to help us to understand when we have questions in a tabular form and we have to find the probability. Now, what this question is telling us is that we have different types of fruits. We have the lemon and we have the orange. Now, some of them are bad, some of them are good. Now, the total of all the lemons, 20. Total of all the oranges, 20. The overall total, we have 40. 5 of the lemons are bad. 15 of the lemons are good. 13 of the oranges are bad, while 7 of the oranges are good. Now, the total of the bad fruits are 18, while the total of the good fruits are 22. So if you have a question like this, that find the probability that a fruit picked at random is bad. Find the probability that a fruit picked at random is bad. This is bad. So just come over here. That will be 9. That will be 18 over the overall. Every segment you pick must be written over the overall total. Please don't make that mistake. Find the probability that a fruit picked at random is bad. We are not told the type of fruit. So if fruit picked at random is bad, that will be 18 over 40. And that is your answer. Probability that a fruit picked at random is good. Just come over here and pick this. This is the total of all the good fruits over 44. Of course, you cut to lowest term. Now, if you are told to find probability of picking a lemon, probability of picking a lemon is 20. This lemon, total of the lemon, 20 over 40. Probability of picking an orange, this is an orange, total of the orange is 20 over 40. You cut the lowest term, in that case you have half. Then if the question asks you, what's probability of picking a bad lemon? A bad lemon, this is it, bad lemon, that would be 5, not over 18, but 5 over 40. Any segment you pick must be written over 40. Probability that a fruit picked at random is a good lemon. This is the good lemon. Lemon, good lemon. That would be 15 over 40. Probability that the fruit you have picked is a bad orange. That will be 13 over 40. And probability that the one you have picked is a good orange, that will be 7 over 40. Just remember that any segment you pick must be written over the overall total. Thank you.
If you enjoyed our teaching, please click like and feel free to share our link with your friends. And do not forget to subscribe to our channel so that you can get notifications of our subsequent videos.